for demonstration number 1, I'm taking some distilled water and I'm adding an acid-base indicator called bromothymol blue, and that will make our first solution. One of the things I'd like you to do is to describe the color of that. It's sort of green, brown, maybe a little yellow. I'm going to pour off a little bit of it into this container, this beaker. A little bit of it goes into this beaker. And a fourth beaker will be used later in the demonstration. Right now, what I'd like you to do is just describe that color. And it's a little hard to describe. There may be a little more blue, a little more green, a little more yellow. And adding them together because they should all be the same shade. And this first one should as well, I think it was. So let me grab the camera and bring it over a little bit closer. I'm going to take a little bit of an acid, I'll use a little vinegar, and add it to this one. This one I'm going to leave alone, and this one I'm going to add a little bit of base to. Plain old vinegar is an acid, commonly used in kitchens for cooking, making pickles, you name it. Used sometimes for cleaning. And I want you first to think about what you think will happen before I do this. And then we add this in. Hopefully you can see something happening. So this is the acid. This is neutral. This one we haven't added anything to. This is still our neutral. And now I'm going to add some ammonia, which is a base, to this beaker. And again, first I'd like you to predict what you think will or might happen. In, and voila, we have a different color change. So again, this is the acid, this is neutral, the one in the center, and the one on the right is got base. Specifically, we used ammonia for the base, and we used vinegar for the acid. So finally, what I want to do is to take some of the original and add a piece of carbon dioxide to it, dry ice. So we get the bubbles happening, but we also get a color change in the solution. As the carbon dioxide turns into a gas, it mixes with the water and produces an acid, one of the acids that we have studied before. And as you can see, the color change is the same as what we got with vinegar. Now, one thing that's different, this vinegar, this will stay acidic for quite a while. The base will stay as a base. This should stay neutral. This is like soda. The carbon dioxide that's dissolved in the water, if I left this alone for a day, 2 days, it would slowly lose the carbon dioxide that's dissolved in there and go back to being neutral color. Demonstration number 4, I'm going to show you floating bubbles. So for demonstration number 4, I'm going to use this aquarium and put some dry ice in it. So we get the effect of the fog. Carbon dioxide has a mass of 44 grams per mole, and it's actually heavier than the air around us. So what I'd like to do is show you how can we tell where the level of the carbon dioxide is. For demonstration number 4, I've put some dry ice in the bottom of the aquarium, a little bit of water in there, and I'm going to use some bubble solution and also a candle to help us figure out how much carbon dioxide is in there. How full is the tank of carbon dioxide? Does it go here, here, here? Does it fill the whole thing up? So if I take the candle and put it into the aquarium slowly, lowering it in, we get down to a certain level, the flame almost extinguishes. And as I bring it back up, it goes again. It's right over here. If I put it all the way down, it goes up. Why? What's going on there? This is for you to think about and decide, but here's another thing that might help you with that. This does not always work well, but hopefully I can get it to work today. I'm going to blow a bubble and try and get it to be in here. Can you see the bubble? I hope so. Now the fog that's being produced actually is something we can see, but normally carbon dioxide gas, we can't see it. It doesn't look any different than air. Let me try. There, finally. You see the balloon? Bounce it up, down, bounce it up, and down. This effect is sometimes used in movies to show special effects. And that's where the level of the carbon dioxide is inside this tank. And the bubble will stay floating there on top of that denser layer of carbon dioxide gas. Let me try one more. No. But you can see the layer of carbon dioxide is bouncing. Okay, so what are the questions? What's inside the bubble? What's on the outside of the bubble?